Okay, Bipin, take it away.
Okay. Hi, everyone. So today we'll go over the trusted firmware Errata process. So agenda looks something like this. Starting with the bug review and categorization, a brief intro on the SDN, the software developer Errata notice, what category of bugs are implemented by TFA, the implementation flow, basically how TFA is implementing that, and then the testing that we do on the Errata. Yeah, some of my keyboard isn't working. Okay, so the bugs are actually found by different flow. It could be like raised by partners. It could be found by internal tools as part of verification, like unit level, top level, hardware platforms, etc. Or it could be like critical security findings at partner or on the field. So internally, there is a forum that actually goes through the different bugs that are found and actually goes through the process of categorizing. So the categorization depends on the impact of the bug, basically the severity, the frequency of occurrence and stuff like that. They go through the different bugs, analyze them, comes up with the proposed fixes possible or the potential fixes possible, analyze it based on various aspects of functionality, performance, power, etc. And kind of proposes the best possible fix for the particular item. So this is actually attended by the stakeholder teams, members who will be like representing the different teams, like say firmware, kernel, etc., the partner managers, etc. So once the bug is reviewed, the categorization of Errata goes like this. In the high level, there are like 3 categories, Cat A, Cat B, and Cat C. Cat A being the most severe. In many cases, there won't be any workaround possible, or it's like the workaround is so impactful that we don't actually provide them. When I say impactful, it could be like severe degradation of performance or actually something of that sort. Then there is a rare thing is based on the occurrence, the use case that actually result in the particular category of the bug is much more rare compared to the non-rare category. So in our firmware flow, typically the Cat A is not something that we address with any Errata fixes. Cat B is actually the significant or critical category with an acceptable software workaround. So again, Cat B also has a rare categorization, which is actually again based on the use case. TFA typically fixes the Cat B erratum, and then Cat C is actually the minor category of the bugs, which we address only based on like requirement from any partners. So SDN, the software development errata notice, is actually the document that holds that applies for a given implementation, and also like the particular versions of the implementation that the erratum is applicable for. It also lists actually the workaround for each erratum that is applicable. So there could be like one or more workarounds that are actually proposed here. In most cases, it is one, but there could be like cases where they propose different based on the configuration. So we go through once the SDN is actually released, we go through the different errata that applies for a given implementation, make sure what is applicable to be like implemented in the trusted firmware, and then goes ahead and implements it based on the availability of the document on the developer.arm.com. So this is to make sure that the patches that are implemented could be like reviewed by others external as well, based on the availability of the SDN. So yeah, as I mentioned earlier, the CAT-B, what TFA implements, it's typically the CAT-B and then CAT-C workarounds if directly requested by any partners, because it may be like applicable for them based on their implementation. And TFA also decides to implement erratum based on the milestones and whether that particular of a particular implementation, starting from EAC. EAC stands for early access, which is actually the revision of an implementation ahead of the first major release of this particular implementation. And at times we actually release even the LAC, which is a limited access version of the CPU. That depends based on requests from partners, and also based on whether the partner takes the particular implementation to silicon. So that's actually the criteria for actually implementing the erratum patches in TFA. So how TFA implements? So typically all erratum are implemented disabled by default. There are like configuration settings that actually kind of enable them based on CPU and the version of the CPU that it is applicable for. Typically the workaround is a instruction patch or actually setting of chicken bit or some register setting during the boot process. So I would say like 80 to 90% of the like erratum patches in TFA falls in this category. More complicated workarounds for erratum that involves multiple components or actually multiple exception levels will involve the firmware or kernel together, for example. So which are like applied during runtime, boot and runtime. It could be a combination of those. So on the right is actually an example of a simple workaround that we implement, the workaround function, how we go through the flow of making sure whether it is applicable for a particular version, and then applying that particular patch or register setting. So this is a simple flow chart of the same, basically, which goes through the TFA build platform. The flow kind of makes sure whether the workaround for this CPU is like enabled for a given platform. If it is enabled, it actually goes through and makes sure whether the CPU that actually CPU version that actually exists in the platform has to have this errata applied, and if that is so, the workaround will be applied. So if it is not applicable for the platform or the particular version of the CPU that is applicable, that is actually part of the platform, then the workaround won't be applied. So testings, so typically the Erratum is actually verified with FVP and Debugger Studio. So as I mentioned earlier, most of the Erratum are actually simple patches which actually involve register settings and stuff like that. So we run it on the applicable FVP version based on the availability and make sure like the register settings are actually, and also kind of make sure the other registers like the GP registers that are part of the that are used part of the Erratum are actually the values before the patch. So these are kind of verified in ARMDS by observing the register contents. So one important point to note here is actually we don't like run any of the verification suites or actually have test cases that replicate the use case that found the Erratum, say for example, the unit level case or the top level case at the CPU verification level, that those are not replicated in firmware and like provided part of the testing. So we also have a FPGA platform to verify more complicated workarounds, especially when you have Erratum that are like spread across multiple components like the firmware and kernel, or in cases where we don't have like the FEP implementing, say, like the implementation specific registers or patch registers that are kind of introduced like in fixing. So if that's the case, we can actually rely on the FPGA platform for verification, especially when the models actually can result in undefined behaviors and there are registers that are not implemented. Yeah, so that's pretty much what I had as part of the presentation. So any questions?
Yeah, I'm not quite convinced with adding erratas without. I understand, you can't reproduce every issue, but applying, I guess applying erratas without knowing if it will work, I don't know, doesn't seem right. So when you say FPGA, do you actually reproduce the issue and then see if the fixes work? I'm just trying to understand how you make sure that a given fix works.
Yeah, I think yeah, this is actually something we discussed before too with some internal CPU team as well. Yeah, actually, it's pretty challenging to replicate the exact use case scenario in an isolated firmware setup. But the FPGA platform where we verify is actually on a case-by-case basis where we, at the moment, it's a case-by-case basis where we don't have availability of FEP, and also cases where we could use the FPGA platform is cases where we can make sure the particular setting doesn't result in a crash or something. But at the moment, the capability is not extended for like an exact use case verification.
Okay.
Hey, Bipin,
Yeah.
Varun here. So
Yeah.
you made an interesting point about crashes.
Mhm.
So there might be a scenario where ARM is always ahead in the IP, and they have some support on their IPs, so they enable these flags. But that same setting might not be present on a partner platform. So do you see that would result in a crash?
Uh, it depends on the, anyway, it's for a given implementation and actually a particular revision of the CPU. So if that's,
Okay.
if it's actually a patch that is part of, say, for example, the boot process, uh, uh, I don't see why it actually couldn't result in a crash in the partner platform if it's the same CPU and revision that is used.
Okay, got it.
Yeah.
And one other point that you made earlier was that the fixes for the erratas are disabled by default, but then you also made a statement that there are some runtime checks.
Yeah.
I'm trying
No.
to understand. I mean, the way I understand these, for me, they seem to be contradicting statements. I wanted to understand a bit more.
Oh no, actually, yeah, I think what I said is actually there are two categories of errata. One could be like the errata that is applied during the boot time, and then runtime is actually an errata that applies during the runtime, which includes multiple components or say the exception levels. Say, for example, an errata that is spread across a firmware and actually the kernel. So the errata is enabled based on the revision of the CPU or the particular implementation of the CPU and the revision through configurations. So if that configuration says this patch needs to be applied for this version, so the errata gets automatically introduced as actually part of the boot flow or the runtime, whichever is actually the applicable fix for the particular one. And as I mentioned, majority of the cases are like boot time kind of actually minor chicken bit kind of settings in firmware. And anything that is runtime is actually probably has like part of the erratum implemented in firmware and say another part actually implemented as part of kernel or the EL1, for example.
Okay, but even the boot time settings for the mitigation can, I mean, they don't necessarily have to be behind a build flag. They can always check the CPU revision version, and then if that, for example, R0P1, just to take an example, if that is affected, then just look at that. You can always detect that at runtime and enable that mitigation. So so are you saying that that is done? Because I see that some erratas that were introduced recently do that. I mean, they check the CPU revision version and then enable it instead of hiding it behind a build flag, because it's very easy to figure that out at runtime. So why do we even have those in build flags and then rely on the platforms to enable them later?
So John, so is that something that actually we have done recently?
Yeah, sorry, if I understand it correctly, Varun, your question, money share. Like, the build flag, I can say like it is only for the minimizing the code size, I guess. Yeah.
Yeah.
In the boot time, we are doing both the things, like checking that during the compilation, if that flag is there, then that particular code is in place. And then at initialization, we'll check the CPU revision and then accordingly apply the errata. So that is clearly being done during the init time. If you see the boot time during the runtime, we generally use only the build flag flag and apply the errata. The reason behind it, like some of the erratas are errata workaround. We don't get the opportunity. Means we have to apply it very fast, and we don't have to do this check over there. So like in case of 80 speculative workaround, we had this problem and we thought of this, whether to check the CPU revision or not. And then we come to the conclusion like we don't need it because we need to apply it immediately once we get to the exception level. So in some particular cases, we really don't check the revision. We just check the build flag and apply the errata for the CPU. So it is up to the build then. Yeah.
Right.
Also different revisions of CPUs have different erratas, right? So you can definitely reduce code size for the same CPU if you know beforehand what CPU revision you have, for example.
Mm-hmm.
So Bipin, if you go back to your flowchart.
Yeah, I'm trying to. My keyboard is. Okay. Yes.
So when you say enabled on this platform, that's a build time check, is it? And the second one is a runtime.
Yeah. Yep. Yeah. Any other questions?
Hey, sorry, Varun again. So for erratas that you know you can have straightforward tests, is there also an effort to introduce those tests, let's say at TFTF level?
Currently, we don't have a suit for like errata test category. Yeah, that's definitely something I note and discuss with the team and get back to you if we can introduce that for at least like for the patches that could be easily verified.
Yeah.
Yeah.
Thanks.
I guess we're dependent. Sorry, carry on, Byron.
Oh, sorry, this is Raghu. So I was just going to ask, so is TFTF run with the erratas turned on too? So for example, if there's an A53 error or something, is TFTF run on those CPUs with the errata turned on?
I think every patch actually, as part of the flow itself, get run with the test cases, right, as part of CI. And
right,
yeah,
but CI does not necessarily enable that errata and run on that particular rev of the CPU, right?
yeah, but this is actually carried out by the person implementing the patch.
Oh, I see. Okay.
Yeah.
So whoever implements the patch will run TFTF.
Yeah.
Verify that everything works, or at least the test passed it.
Yeah. Actually, we have to make sure actually there is no new failures that are introduced by the patch. Yeah.
Thanks.
So I was going to say, we're dependent on the CPU team to sort of give us guidance on what the workarounds, the mitigations we need to apply. Where we can, of course, we can do some checking as we're implementing the mitigation, but the issue it's trying to solve is fixed, but sometimes that's very difficult for us to do. What we do primarily target is to make sure TFA, with the mitigations applied and not applied, we still we still operate, and all our tests that we have all pass still, and the mitigation itself doesn't break TFA.
I would like to clarify something, but please correct me if I'm wrong. So we run our CI on FEP models and Juno, and the FEP model by itself does not model the bug. So whether the applying the errata or not may not make much difference. There is no way for us to validate that. I just want to be clear on that.
Yeah, that is
Yeah,
that is sure.
Yes,
yeah,
but
that's a valid point.
yes.
But at the same time, yeah, there could be FEP versions based on what erratum, a particular erratum may be possible to be verified versus some may not have any.
Most of the
yeah.
Sir, most of the bugs are micro-architectural, and FEP is architectural envelope model, right? How would it really model a micro-architectural bug, and why would it model a bug, right? That's my concern.
Yeah, again, as I mentioned, it will be like purely based on the particular erratum that you're talking about.
Okay, right.
Yeah.
I mean, part of introducing FPGA testing is it's a little bit closer to the real silicon than the software model. Not ideal, but it's to give us another type of test platform that we can check. And again, it's all erratum, the particular issues, whether it could be replicated in that environment. Very much like you're saying, Madhu. If we can't replicate. Yeah, if we can't replicate the underlying issue, all we can do is check that we've followed the guidance that the CPU team has given us of what they tell us that we need to do to mitigate against the issues that they have or they've identified.
Right.
Yeah, so that usually makes that makes total sense, especially if it's like workaround like setting chicken bits or something like that. Yeah, that's I think those should be okay, right? But I was thinking of erratas like this, the recent speculative AT thing, AT issue, right? So yeah, we did have a fix that we thought was right, but it was not fixing the issue at hand, and could potentially cause performance degradation, right? So those are the kind of situations that would be nice. And well, I guess even the errata notice for the CPU was extremely vague, so that did not help either, right?
Mm-hmm.
So yeah, I'm just trying to think what we can do to avoid those kind of situations where we think we have a workaround, but it actually does not work and degrades performance, right? So that's the worst case situation. So it just so happened somebody noticed that we had the workaround that wasn't correct, so we're able to fix it.
Yeah.
Well, I'm going to do a plug here for the OpenCI that if partners have got real silicon, that are making use of some of these erratums, or if they're willing to incorporate them into the OpenCI platform testing, that gives us another route that we as a TFA project can make use of.
Yeah, yeah. Actually, the AT instruction is one example where the test case could be like more complicated, especially from a verification of an errata patch perspective. But I get the point, because if the degradation of the performance with the use of this, the particular patch also needs the particular use case that could bring out that degradation of performance. But if provided the case is there, say for example, a trimmed down kernel working with TFA, part of the FPGA platform, and if you have the case, we could at least actually do a comparison of performance before and after, with or without the patch, for example, which could be done. But the example case is probably a bit more complicated for the like TFA test suite perspective. Yeah.
Right. Yeah, I'm not saying I have the solution here.
Yeah,
I'm just saying, yeah, if we do have something, that'll be great. I have no idea how to
yeah.
make sure we don't end up in the worst case situation.
Yeah, I get the point
Something to
actually.
think about.
Yeah. Definitely a good
Yeah.
point. We'll kind of make a note of it.
Yeah, this particular errata speculative was really a complex one. Even I myself had trouble understanding it, and I think that's the reason I think it didn't go well first time. But I think Manish, who actually gave the patch, also did a lot of discussions before pushing out that workaround.
Yeah.
Yeah, and to be, I think this, I think I might be wrong on this, but when we are referring, it actually represents our team here, but it may not completely represent every other team in ARM. Maybe there is some other team, CPU team, that is actually also doing some kind of validation on this.
No, actually the CPU team does verify. For example, they have, say all their different levels of verification, whether it is unit top. Typically when a bug happens, especially on something that is in the field, etc., it's a pretty high priority task to verify or even replicate at different levels.
Right.
But the only thing is the integration between that effort and this. These are like two different teams. But they do verify, and actually
Right.
that's a guarantee on which we actually apply the patch. But then the particular case that we are talking about, the speculative workaround, is actually an extreme case because
Yes.
there was actually even confusion in the SDN itself.
Workaround.
Yeah. Okay, so yeah, that's all I had, Joanna. Over to you.
Okay, if there's no more questions there, if you want to stop sharing your screen, we can do what we traditionally do. Bear with me while I find the right UI. I don't think my screen is sharing. Let's try that again. Too many windows. Where's it gone? Oh, there we go. Are you seeing my TFA Technical Forum TFA agenda screen?
Yes.
Yeah.
You are good. It's all right. Normally there's a big red or green line around it, but right. So traditionally we this point, if there's no more questions about the presentation, we can review what's happened in the mailing list over the last few weeks. We missed the last TFA Tech Forum because we didn't have a subject to talk about. So this is, if you can see the archives. Does anybody have anything from this list that they want to follow up on and talk about today? Not sounding like anybody has. I probably want to take a bit of time, I guess, really just to remind folks that in the trustedfirma.org, under the latest, there's the meetings area, and in there you will see TFA listed. If you click on there, you will see all the previous sessions and all the recordings and the presentations. There's also a scheduling tracking page that I use to try to track things that are possibly being prepared and who's doing them. More than happy to take any subjects that you guys, partners, that would want to talk about, contributors to the project. And I know Varun himself is looking to present something in a future session. But if anybody else has got anything else they'd like to talk about and present and discuss, please reach out and let me know, and I'm more than happy to try to schedule something. you can probably see we do have some other subjects that we haven't prepared material for that we hopefully eventually will get to. But rather than the sort of the ARM team, dominating this, if partners have got anything they want to talk about and present to the project, please reach out. Is there any other questions, any other business, any that's urgent on folks' mind? I'm not hearing anything. So if there's nothing else, I think we might be able to finish the meeting early today. The next one is in a couple of weeks. I think 10th of September, 2 weeks today. We'll have a subject there. As I said, Varun is interested in possibly presenting then, but if he can't make that one, we'll try and fulfill some of these other items that we've got. Unless anybody else, as I said, partners, contributors want to contribute anything to the meetings. Okay, if there's nothing else, I will call the meeting over and give 20 minutes of everybody's time back. Thank you for coming today.
Thank you.
Thank you. Bye.